So, with that said, anchors away, heave ho. Let's start the missing mast with Charity.
Yes. She is the grand dame of infrastructure, the CTO of Honeycomb.io, and she even co-wrote a book on database reliability engineering. I think that she knows what she's talking about. And I also heard, she's wrote a book on database reliability. I thought, well, she might have an idea for testing, how to do that with giant data sets. And then I was told she does it in production, which I think, I'm going to learn something today.
For sure.
I want to have a nice round of applause for her. Charity.
Okay. Am I on? I am on. Yay. It's really my favorite thing about this talk is just getting to see the horror in some people's eyes when I say the phrase testing in production. All right, we'll wait for my thing to come up. I have had such an interesting time getting here. Directions are hard. Anyway. I don't want to proceed beyond. I have this very pretty thing that I just finished 30 seconds ago, so I'm going to leave it up there. But I will say that I brought a lot of really snarky Nietzsche quotes, stickers with unicorns and rainbows, and they say angry things about technology. And I'm going to leave them in the speakers lounge, so you should come and get some afterwards. They're the ones that say like 20 fucking tools and no two agree. Yay, there we go. See, isn't that pretty? Yay. It's kind of like the English governess who's always like, a spoonful of sugar. I find that like a spoonful of rainbows helps the anger go down. My name is Charity. This is already in the intro. If you have the book Database Reliability Engineering, you'll notice it has a horse on the cover, but I brought stickers so I can fix it for you. See me after class. You can't apparently have a mythical creature on your book if it's O'Reilly. I think that's bullshit. Am I going to get in trouble for swearing here? It's Europe, right? Yes? Yes. All right, I'll do my best. So, test and prod. Some reactions that I often get are, that sounds like things that cowboys do. Or like, isn't that the battle days of sysadmining? It's gotten a bad rap. And I blame this guy. Because it's such a great meme. Like, who of us has not had it up on their wall at some point? It's so funny, and he's so cool. He's just like, I don't always test my code. When I do. It's funny, but it's so wrong. Responsible engineers test in prod constantly. And irresponsible engineers do too, they just don't admit it, and so they do it very poorly. First of all, it starts with it's kind of a false dichotomy. It sets it up as though you can only do one or the other. You can only test before or after, which is, one hopes, not true. And I do want to make it clear, a lot of people seem to just take the title and then run off and go, Charity says I don't have to do tests anymore. And that is not what I'm trying to say. I do have respect for, all the traditional tests. I think that you can often spend less time doing that. 80% of the 80% of the bugs can be caught with 20% of the work. Don't have to ask me. You can ask Katie McCaffrey, who's done computer science. I'm a music major, so don't ask me anything about math. But when it comes to testing in production, we waste a lot of our energy, honestly. And we waste it because we want to do a good job, which is a very good motivation. But we waste it because we think that there is such a thing as safety, and so we chase it. And it's just a fact of life that the scarcest resource that any of us has will always be developer cycles, right? Engineering time. It's a finite set, even if you're Google. Even then, you have a finite amount of time and energy. And it sounds great to go, let's catch all the bugs, let's test all the things. But in reality, is that the best use of your time? Maybe not always. Anyway, I won't get too much into it. Please test. Please test. But tests are great for catching the problems we already know about, right? They're good for the known unknowns. As soon as you find a way that your system is going to fail, you write a test for it. Yay! Now we'll know if it happens again. Over time, the set of things that you know about how your system can fail should grow and grow, and it should get better and better at not doing those same things again. But tests are for developers, kind of like monitoring checks are for ops people. And our systems are changing in ways that make these old tools catch less and less of the problems that we actually deal with. This is such a meme-heavy topic that I just had to throw a couple more in there. But let's look at some definitions. Testing, checking the quality, right? And production, where your users are. And every interesting thing that happens comes at that conjunction of an artifact of code, an infrastructure, point in time, and an unpredictable user action. And every interesting thing is an unknown unknown. So the traditional path of the deployment thing goes, you write your code, you commit it, it gets automatically rolled out to some staging thing, runs all the tests on it, roll up an artifact, deploy to production, or promote it. But staging is not like production. I know, shocker, right? It will never be production. You cannot clone production. Even if you think you do, you're wrong. You will always be wrong. And it's better to just accept that it's wrong and not try and just accept the limitations of staging. And I will go so far as to make a maximalist point, which I will not 100% defend, and say that most of you can probably get rid of staging altogether and just run things on your laptop if you take that effort and you apply it to production, to hardening it, to building guardrails, to making it safe to do things, increasing your visibility and your observability. It's not just get rid of staging and YOLO, but a lot of that time is better used elsewhere. Staging at its worst is worse than nothing at all. Has anyone here ever lost a day to trying to track down a bug in staging that didn't exist in production? Sorry, a week? Has anyone not lost a month? This time adds up. And it is the fact that every single moment that you spend in a false environment is not neutral time, it's negative time. When I think of senior engineers, I think of engineers whose instincts I trust, right? Yes, we'll be data-driven, blah, 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 but if they're I have a bad feeling about this, for senior engineer, I want to, okay, let's think about that, let's unpack it, why? And the more time you spend in staging, the more time you're building up your muscles, your intuition to think that, say, things like drop database blah are fine. Those are not good instincts. The more time you spend running queries in staging, the more you're learning about what's fast, what's efficient, what's okay to do, what's not. But you're learning the wrong lessons. I believe that increasingly every single one of us, even client-side developers, should be spending a lot of time immersed in production, knee-deep, if not neck-deep, say neck-deep. Because that's where you learn the instincts, that's where you learn the lessons that actually make you good at your job. All right, I'm not saying that everyone has to get rid of staging, but I would. You're not going to understand your code at all unless you watch it run with real data, real users, little agents of chaos, real traffic, real scale, real concurrency, real network, real deploys, everything. Real what?
Real money.
Real money. Oh yeah, it's hella expensive to spin up a copy. So why now? Let's backtrack just a little bit. Because for a long time, this really was the best practice, right? Build all these elaborate environments, automate the whole thing, gain confidence by running all these tests. Well, I mentioned not being a math major. but I drew you a graph so you know that it's true. By my calculations, things are getting more complicated. We toss this word complexity around a lot, but what does it actually mean? What is the complexity of systems? Well, let's visualize this. There's your lamp stack, humble one on the right. And let me just start out by saying, if you can solve your problems with a lamp stack, please do. They're great. Unfortunately, more and more of us cannot. That middle one is parse. Anybody here use parse? Mobile backend as a service? Yeah. Any Facebook people here? Then I can say how I will never forgive them for shutting it down. I will hold that grudge for the rest of my life. Assholes. That was Parse's infrastructure, 2015. And like that middle blob is like a few hundred MongoDB replica sets running queries that we just let developers all over the world just upload, and we just had to make them work. Co-tenancy problems, what? JavaScript, you got to write JavaScript, upload it, and we just had to make it work, right? Reasonably complex. Running this system is what directly led to me starting Honeycomb. And it gets worse, right? Like this is the national electrical grid. And this increasingly is like what we need to have in our heads as a mental model for how we're building systems, right? There are emergent behaviors that no one understands, and that's fine. Things break constantly, and it's fine. Some problems are hyper-local, like a tree fell over in Main Street in a small town in Iowa. No one could have predicted it, probably. No one should have put a lot of effort into trying to predict it. No one should have written a unit test for like that tree. Is this tree going to fall down today? You just have to like repair them and move on with your life and make things resilient so you can run around it. Some problems are like the opposite of that. Some problems you can only see if you zoom way out. Like if all of the bolts that were manufactured in 1972 are rusting 10 times as fast and you want to proactively replace them. Right? Like there are just these categories of problems that you look at them and you're like, yeah, I should not put any effort into trying to predict this whatsoever. I should just invest in my observability so that I'm detecting information at the right level of detail so that I can ask any question of my systems and understand it without having to ship new code to handle that occurrence. And this roughly tracks, observability is for unknown unknowns, the way monitoring is for known unknowns, et cetera. But like the overall message of this is just stop trying. Just give up. So many catastrophic states exist right now in your systems, and it's fine, more or less. Sleep tight, though. And this matters more and more to us. We're all distributed systems engineers these days. And honestly, like, who are the first OG distributed systems engineers? Web engineers, right? The proliferation of clients is what got us all into this mess. So increasingly, like the problems that we have in our systems, like it used to be, and I come from ops, right? It used to be that the problems we have in our systems were like, you could look at a system, your lamp stack, predict 80% of the ways it was going to break. You write a bunch of monitoring checks for them. Over the course of the next 6 months, you would learn the other 20%, and you write checks to handle them. And it was pretty rare that like something really new happened. Like usually you get paid, you go, that again. You trundle off to repair it. We don't do that anymore. Things that were just like, that again. We automate them out of existence, right? It's more like now, every time you get paid, it should be something genuinely baffling, right? It should be something that you couldn't handle automatically. It should be unknown unknowns. And there are more and more and more of those because of the interactions between all of these ephemeral components, blipping in and out of existence, users. Need I even describe it? I'm sure you're on the same page. And distributed systems are incredibly hostile to being cloned or imitated or even monitored. At Facebook, we were not going to spin up a copy of Facebook to test Facebook, right? It's not financially practical. You're not going to spin up a copy of the National Electrical Grid to monitor the National Electrical Grid. And even if you did, it would be kind of pointless because if it's not users bringing their chaos and trying new things, it's boring. And And you don't actually care how things fail in false environments. You do care intimately about how they fail in production. And distributed systems have this like infinitely long list of things that almost never happen, except that one time they do. Or it takes like 5 of them at once to trigger a bug. And then you spend like a week of your life trying to repro it in staging. Like I said, give up. Don't. You don't care. It's probably not going to fail the same way in staging as it did in prod anyway. Staging's not production. It will never be production. Staging is a black hole for your time and energy, and a misleading set of results that will mostly result in misplaced confidence in your code. And it will suck away your life force and your will to live. Like I said, this is why I bring the rainbows. And like, how well do you even understand and notice problems when they do happen, right? Like, only production is production, and people will argue me down. They'll be like, well, I work on this system where I can, like, I spin up a copy of it to test it every time. I care so much about not breaking anything. But it's actually impossible because every single one of these deploys is a unique process. You cannot, as anyone who's ever typoed production knows, you can't actually test everything. And by the way, deploy scripts are production code. Not only that, but they are the most important code in your system, in every system. Which is why I don't know why we give it to the interns. Why don't we give it to senior engineers? Furthermore, I see people sinking all this time and energy into staging when they can't explain what's going on in production. That's where you should be putting your effort. If you can't explain any spike, like instantly, screw production. Screw staging. It really throws me off not getting to swear. Screw staging. Like, until you have a good enough observability that you can explain anything that's happening to your satisfaction, you should not be pouring more energy into staging. Katie gave this great talk at Papers We Love. The link is there. I will post this. Where they showed that actually 80% of the bugs are found with 20% of the effort. And so I'm arguing here for taking a lot of that energy that we're putting into staging and shifting it to production. Because, like I said, you have to watch your code run with reality, right? The best software engineers I know have like a window open with their IDE and a window open with their observability tooling. And they're constantly in a conversation with their code in production. They're watching users use it. I feel like it should be muscle memory for every engineer, that as soon as you ship code, you go and you look at it. You're instrumenting it, right? So you're going to know if it broke. So just go look at it through the lens of your instrumentation and see, is it doing what you expected it to? Does anything else look weird? You will catch like 80% of the bugs that you ship before users even get a chance to notice. You do have to have tooling that's capable of it, but I'm not going to do a pitch here. Suffice it to say it exists. Our idea of the software development lifecycle is super overdue for an update because we have this idea of it. In our mental model, it's usually a switch, right? You flip it off, you flip it on, you flip from one version to the other. But it's manifestly not. Deploying code is not a binary switch. It's a process of increasing confidence in your code. Just like developing code is not committing it to master and walking away. It is committing to master and then owning it until it's sufficiently stable for your users. If you're deployed, this is the world that exists in most managers' minds. It's a lovely world, not the real one. But instead, we have continuous deployments and rolling releases and feature flags and cherry picks and rollbacks and failed rollbacks and the occasional yeah, there we are. And the occasional, well, I don't really know. It's just kind of a mess. And then on top of that, we're like, chaos monkey! Let's do some chaos engineering. Oh my God. We have to recognize that the development process extends way into production. And not only that, but the production system extends way into development, because anytime like a team uses a tool and another team uses another tool, like those tool boundaries are what create silos. And I'm so sick of like having a tool set that you use while you're developing, and then you're in a whole new land with production, and that's not okay. You should feel comfortable there. These should be the same tool sets knitting together, like the beginning and the later stages of your code, because no two tools are going to agree on reality. And so if you're not using the same tools, you're not going to agree on reality, and this is just going to lead to conflict. All right, you want to gain confidence in your code, and that means watching it. It means having the tooling to look at what's actually happening, and it means showing some curiosity. This may seem remedial, but I will say it again: staging is not prod. You can't clone the data, usually for security reasons. You can't spin up a copy of it, and yet we have to make some kind of declaration of what we're going to do with it, right? So what should we do how should we test before prod, and what should we test after prod? Let's see. Test before prod. The basics, right? All of your known unknowns. Does it work? Does it run? Does it fail in the ways, the library of things that I can predict that I've built up? Does it fail in the ways that it's previously failed? This is what some people think of when they say testing. But then there's all this other stuff, right? Like experiments, edge cases, canaries, progressive deployments, data migrations, load tests. I know of more than 2 people who run a continuous 20% load test on their systems. Whenever they run out of room, they have 20% to like turn off and buy them some time. I think that's a great idea. It also like helps them find scaling edges really nicely. Yeah. More reasons. Chaos engineering outside of prod doesn't even make any sense. I don't know. I'm not really a big fan of chaos engineering. I think it's just like operations with the new branding. By the way, if you are doing chaos engineering and you do not have observability, the kind I was talking about, you're not chaos engineering, you're just chaosing. Let's be clear. Beta programs where customers can try new features. Facebook had a really robust way of rolling out changes where as soon as you committed, it would merge to, we called it Sandcastle, spin up a whole isolated testing environment, run days worth of tests against them, and then build an artifact, and then it would deploy it first to a small section of Brazil. I'm not sure what Brazil ever did to them, but Brazil it was. And then it would slowly, graduate to more and more of Brazil, and then like more of South America, and then like more all over the world. And it took a few days for a deploy to go fully out, and they would have dozens of versions in flight at any given time. And this was really terrifying to me at first. And then I realized that with high cardinality tooling, it's not. You can just break down my build ID. It's really nice to be able to compare them. Deploys are often the tip of the spear when it comes to getting software engineers to do stuff in prod, for obvious reasons. So if you're looking for some place to start, I recommend that. Like, everybody should be curious about what happens to their code when it hits users, right? How many of you here have root? How many of you deploy your own code? Nice. How many of you think I'm absolutely insane and wrong about everything? Oh, you liars. There's got to be some of you here. There are some areas where you do want to be paranoid. The closer you get to the data, like laying bits down on disk, the more paranoid you should be. And I come from the database side of the house, right? And I have written a piece of code 3 times for 3 different databases that all it does is sniff 24 hours worth of production traffic for a shard or a replica set or whatever, and then take it offline, and then you can replay it and like adjust the concurrency levels and this sort of thing. And I have done that every time I've had to do a major version upgrade for my database, and every time I have gone, oh my God, I cannot imagine how fucked up. Sorry, how screwed I would have been if I had not done this. Like, databases are terrifying. But if you aren't a database person, there's basically no reason to do that. Some other terrifying things to do are like rewrites, right? Doing a rewrite from one language to another is justifiably terrifying. So you might want to do something like teeing. So like the request comes in, and instead of just hitting an app server, it hits a splitter. And the splitter goes to a version of the old API server and a version of the new one, diffs the result, and returns the old API server result to the user, so they don't see anything different, but you can just like review like all of the drift. And then you can actually daisy chain two of those if you're doing testing mutating data endpoints. That's pretty cool, although don't rewrite if you don't have to. Anyway, test and staging. I mean, I'm not going to get super religious about this. You can if you want to. But, you know, I feel like we have a very low standard for our tools. How many of us have had just a wall of green dashboards while users are complaining loudly? Everyone. I guarantee you don't have zero problems. Anyway, some of the real risks, like I was saying, you could expose some security vulnerabilities. You need to think carefully about namespacing if you're going to run continuous, say, load tests along with your regular traffic. You're going to want a way to reap it, delete the data, expire it, end-to-end checks, tenancy issues. The app could die. You could saturate a resource, although you could arguably say that this is a good thing because you would find out that you were going to saturate the resource and you could just turn it off. Chaos does tend to cascade, so there is that. And much like Martin Fowler said about microservices, if you're not this tall, you should not ride this ride. Same applies. But the cardinal rule here is not that nothing can break. All kinds of things can break. It is fantastic how many things can break before you have to care. Because the cardinal rule is just a user can't notice. Do you know how much stuff can break before a user has to notice? It is glorious. And this is a fun way to kill a month or two, just like see what all you can break. How much can you break before anyone actually has to notice? It's probably more than you think. Like, because reliability, like, one of my life missions is to make this a profession where every engineer can be on call and support their code, and it doesn't suck, right? It shouldn't be life impacting. It shouldn't be something you have to plan around or that wakes you up. You should be over 40 and be totally happy to support your code in prod. And this is an achievable mission. I have seen it achieved. I have done it. It is not pie in the sky. It's not crazy. But it does require getting used to dealing with failure. The way that we get to this glorious place is not that we make things break less, because that's just never going to happen. It's we make it so that lots of things can break without it impacting our users. I find this a very optimistic worldview. Right? People differ. Also, build or use. It is now completely possible. Even like 5 years ago, if you left Google or Facebook and you kind of went out into the real world and went, whoa, I'm really like flying without a net here. There is no tool chain that is anywhere near like what I'm used to dealing with. You can put together a pretty good composable set of like a Google-ish or Facebook-ish pipeline using tools like this. Feature flags, high cardinality tooling, shadowing systems, etc. And by the way, please don't build your own. And I don't just say this because I'm a vendor. I say this because it's stupid. So many swear words, tip of my tongue. It is stupid. It is monumentally stupid. Unless you have infinite engineering hours, in which case, be my guest. But like, who does? I assume you don't. I assume you have better things to do with your life. Support the ecosystem. Be less afraid, right? These are safety nets. Bring your designer into next time when you're working on your deploy code. Ask your designer how we can make things that are easy, that are safe, easy, right? And things that are dangerous, hard. They're really good at that. And for too long, we have been building systems for engineers instead of humans. Engineers are not who you want to build for. Human beings are who you want to build for. Remember that whoever uses it is going to be like 4 a.m. and probably drunk. Be less afraid. But the only real way to be less afraid is to get used to playing in production. To just get used to breaking it and fixing it and breaking it and fixing it and realizing that the world keeps on spinning and everything's going to be okay. Failure's not rare. No way to make it rare. Nobody has yet figured out how to make it rare. It's probably not going to happen for you. But production does not have to be scary. Failure is when, not if. So does everyone on your team, everyone who has the ability to merge to master, should know what normal looks like? If you only look at your system when things are down, you don't know what normal looks like. Your intuition has not been correctly fed. If you don't know how to deploy and roll back, if you don't know how to get to a known good state before you have to escalate, you're going to be terrified. If you don't know how to roll out slowly and under controlled circumstances, and how to ship scary changes, how to debug your code in production, then you are going to be terrified, and you should be. So just learn those things. You'll learn it's not that hard. And then tonight we can test and prod. All right, I think that's it. Yep, that's it. Sweet. Thank you so much. 20 seconds left.
Oh yeah, you're doing quite well.
Not bad, not bad. We've got some pieces of 8 for you.
Presents! Oh.
Exactly, presents.
you.
Thank you very much.